What if the secrets to our climate crisis aren't in futuristic tech, but buried in ancient ruins? From the fall of empires to the rise of forgotten civilizations, history whispers urgent warnings about environmental change. Could their successes and failures hold the key to our survival?
Welcome to our world of discovery and adventure. This channel is all about exploring the unknown, explaining the incredible, and revealing the truth behind the most fascinating topics on Earth. If you love learning something new every day, you're in the right place. Now we explore, explain, climate and collapse, lessons from history's environmental shifts.
The story of humanity is inseparable from the story of the Earth. Long before the first city was carved from stone, long before empires dreamed of ruling horizons they could barely fathom, the shifting moods of climate sculpted the fate of every living being. The wind, the rain, the ocean, the sun, all of them were silent rulers whose decisions determined who thrived, who struggled, and who vanished. This documentary journey begins not in the present, not with factories or carbon charts, but deep in the ancient past where humanity first learned that nature could nurture and destroy with equal devotion. Across continents, through forgotten civilizations, through ruins swallowed by sand, ice, and jungle, the Earth has preserved evidence of how climate shaped triumph and tragedy. To understand our future, we must listen carefully to these stories, because the Earth remembers, even when we do not. Humanity's relationship with climate began as a fragile dependence. The earliest communities of hunter-gatherers moved with the seasons, like shadows following the sun. They understood nature intuitively, not through data, but through survival. When rains failed, they traveled farther. When rivers swelled, they adapted. When cold advanced, they fought or fled. But nature had a larger rhythm, a cycle of warmth, ice, monsoon, drought, that played out over centuries and millennia. The first great climate shift that shaped human destiny was the end of the last ice age, a transition that melted ancient glaciers, lifted sea levels, reshaped continents, and opened lands that had been frozen wilderness for tens of thousands of years. Entire ecosystems changed, and with them, human possibilities. Around 11,700 years ago, the Earth warmed abruptly, marking the beginning of the Holocene. Forests expanded over lands once buried in ice. Rivers carved new paths through thawing terrain. Animals migrated into previously inhospitable regions. Human societies transformed in response. The warmer, more stable climate allowed plants to flourish in predictable cycles, and this consistency encouraged early humans to experiment with cultivation. What started as a few scattered attempts at gathering and planting gradually evolved into the revolutionary practice of agriculture. The Fertile Crescent, China's Yellow River Basin, the Indus Valley, and the highlands of Mesoamerica all became birthplaces of farming because climate offered them regularity. Enough warmth, enough rain, enough seasonal rhythm to sustain crops. Yet climate was not a benevolent force. Its gifts came with conditions that humans never fully understood. As populations grew, settlements expanded, and agriculture became a foundation of life, a subtle contract formed between humanity and nature. People believed they controlled the land, but in truth, they merely lived within the tolerance of the climate they inhabited. Whenever the climate shifted, the balance was broken, and societies that once flourished suddenly found themselves vulnerable. The echoes of these collapses stretch through history like warnings carved into time. One of the earliest such environmental shocks was the 8.2 kiloyear event, a period roughly 8,200 years ago when global temperatures plummeted for over a century. Scientists believe that a sudden release of vast meltwater from the glacial lakes of North America disrupted ocean currents, leading to abrupt cooling across Europe, Africa, and parts of Asia. For early agricultural communities still learning how to coax crops from the earth, this unexpected chill was devastating. Harvests failed, Rivers dried or flooded erratically. Livestock perished. Archaeological evidence shows widespread abandonment of early farming settlements. In the Fertile Crescent, the cradle of civilization, people retreated to smaller, more secure communities. Some groups returned temporarily to hunter-gatherer lifestyles, unable to rely on agriculture in an unstable climate. Although humanity endured, this event revealed a crucial truth. Even small climatic shifts could unravel lifeways that people believed were permanent. Generations later, when humans built their first urban centers, they carried with them both ambition and a fragile hope that nature would remain steady. But the Earth is never still, and climate has never been predictable for long. As the millennia progressed, complex societies emerged across the world. Each believed at its height that it had mastered its environment. The Sumerians developed intricate irrigation systems to tame the unpredictable floods of the Tigris and Euphrates. The Egyptians built an entire civilization around the Nile's rhythms. The Indus Valley cities designed sophisticated drainage, while the early Chinese dynasties crafted intricate agricultural calendars based on celestial movements. Everywhere, climate shaped possibility, and humanity responded with ingenuity. Yet, even the most innovative societies remained dependent on nature's stability. A shift in monsoon patterns, a prolonged drought, or an unexpected freeze could unravel centuries of progress. The story of climate and collapse is therefore not a single tale, but many. Each chapter reveals how environmental changes intertwined with political fragility, economic pressure, and social unrest to topple civilizations often considered invincible. At the same time, these stories highlight resilience, the way some societies adapted, migrated, or reinvented themselves to survive climate's challenges. To begin exploring these historical lessons, we must step into the ruins of ancient Mesopotamia, widely considered the cradle of civilization. Around 2200 BCE, a mysterious and catastrophic climate event triggered one of the earliest recorded societal collapses. Known today as the 4.2 kiloyear event, this period brought widespread drought that lasted centuries. Rainfall declined sharply across the Middle East. Rivers shrank, crops failed, and pastoral groups began migrating in desperate search of water and fertile land. The Akkadian Empire, once a formidable political force that united vast territories from the Mediterranean to the Persian Gulf, crumbled under the weight of famine, conflict, and environmental decline. Contemporary tablets speak of the Great Hunger and the winds of evil that swept across the land. Archaeologists have uncovered layers of dust and abandoned cities, evidence of massive sandstorms that buried once thriving settlements. The Akkadians had created one of the ancient world's most advanced bureaucratic systems, but no administrative power could command the sky to rain. As the drought intensified, trade routes faltered, and internal rebellions erupted. The empire fractured, and its people dispersed into smaller city-states, each struggling to survive in the harsh new climate. This collapse, driven by environmental stress, left a profound mark on the region. It reshaped political boundaries, altered cultural landscapes, and forced societies to rethink how they used water and land. Yet it also demonstrated the fragility of even the most powerful human institutions when faced with climate shifts beyond their control. The world would witness similar patterns repeatedly. Climate change destabilizing food systems, weakening governments, triggering migrations, and igniting conflicts.
Following the downfall of the Akkadians, other societies rose and fell in similar rhythms. In North Africa, The Sahara Desert once supported grasslands, lakes, and human settlements. Between 9,000 and 6,000 years ago, the Sahara was a green paradise, dotted with wildlife and sustained by monsoon rains that reached far north of their current boundaries. People thrived there, leaving behind cave paintings of cattle, fishermen, and abundant water. But as Earth's orbital patterns shifted, monsoons gradually retreated southward. The Sahara dried over centuries, turning into the vast desert we know today. The pastoral groups who once lived there migrated toward the Nile Valley, contributing to the formation of ancient Egyptian civilization. Thus, even Egypt, a land that would become synonymous with stability, was itself a product of climate migration. The river's reliability allowed a civilization to flourish, but Egypt too faced periods of environmental stress. Droughts and erratic Nile floods repeatedly tested the kingdom, especially during the First and Second Intermediate periods, when central authority weakened. In inscriptions and papyri, Egyptians wrote of years empty of inundation, when famine spread and social order unraveled. Nature was both the giver and taker of Egypt's prosperity. Climate shaped societies across the globe in similar, profound ways, but the pattern was not uniform. Each region responded according to its geography, resources, and political strength. In China, early dynasties wrestled with the Yellow River, a waterway known for both fertile silt and devastating floods. When the climate cooled and rainfall patterns shifted during the Late Bronze Age, hardship intensified. Crops suffered, migrations increased, and the political stability of ancient Chinese states was threatened. Yet China developed unique strategies to survive, from flood control systems to diverse agriculture that could withstand variations in climate. Meanwhile, on the far side of the world, indigenous societies in the Americas were building sophisticated cultures deeply in tune with their environments. The Maya, for instance, created intricate cities in the rainforest, complete with reservoirs and agricultural terraces. For centuries, they flourished, but when rainfall declined and drought cycles intensified between the 8th and 9th centuries CE, the Maya world experienced dramatic collapse in its densely populated southern regions. Cities were abandoned, political structures fell apart, and populations dispersed. Climate stress interacted with warfare, resource depletion, and political fragmentation to trigger a multi-century decline. These examples illustrate a key lesson. Climate rarely acts alone. Environmental shifts create pressure, but collapse emerges when societies fail to adapt, overexploit resources, or become entangled in internal conflict. The lesson of history is not that climate change inevitably destroys civilizations, but rather that it exposes their vulnerabilities. The story of human resilience is just as important. The Vikings, for instance, sailed into the North Atlantic during the medieval warm period, when milder temperatures made Greenland's coast more hospitable. But when the Little Ice Age brought harsher winters and shorter growing seasons, Norse settlements in Greenland declined and eventually disappeared. Yet the Inuit people, who had centuries of experience living in Arctic conditions, survived through adaptable techniques, such as hunting seals and building insulated dwellings. Climate did not eliminate life, it punished inflexibility. Throughout history, societies that diversified their agriculture, developed robust water systems, engaged in long-distance trade, or maintained flexible political structures were better equipped to withstand environmental shocks. Those that relied too heavily on a single crop, a single river, or a rigid system of governance faced greater risks. This theme repeats itself from the Bronze Age to the present day. In the heart of South Asia, where rivers once flowed with seasonal grace and the monsoon breathed life across fields of barley, wheat, and cotton, a civilization emerged that would become one of the most sophisticated of the ancient world. The Indus Valley Civilization, also known as the Harappan Civilization, was a marvel of engineering, planning, and cultural harmony. Its cities stretched across a vast region spanning modern-day Pakistan, India, and Afghanistan. Harappa, Mohenjo-Daro, Dholavira, and dozens of smaller settlements formed a network bound together by standardized architecture, meticulous urban design, intricate drainage systems, and far-reaching trade routes. Yet, like many great societies before and after, the Harappans faced a challenge they could neither control nor fully understand: a shifting climate that slowly tightened its grip until the once thriving civilization withered into obscurity. Their story is a testament to how environmental changes can unravel even the most stable societies. For centuries, the Indus Valley Civilization flourished during a climatic period that favored robust agriculture. The monsoon, the lifeblood of the region, provided predictable rains that filled rivers and nourished fields. The Saraswati River, once a mighty watercourse flowing parallel to the Indus, served as a central artery for many settlements. But around 2200 BCE, a series of gradual yet profound changes began to emerge. Monsoon patterns weakened and rainfall steadily declined. Rivers that once swelled with the energy of seasonal rains began to shrink. Archaeological and geological evidence shows that the Saraswati dried up over generations, turning fertile plains into arid landscapes. The Harappans, who had built their world around the rhythm of these rivers, suddenly faced a crisis that shook the foundations of their society. At first, they adapted, as humans have always done. They shifted from large city centers to smaller settlements, moved eastward toward regions where the monsoon still offered some reliability, and diversified their agricultural practices. Yet the stress mounted. Trade networks dependent on surplus production began to falter. Without enough surplus to exchange for materials like copper, tin, or precious stones, craftsmen lost their livelihoods. As economic pressure intensified, political structures weakened. There is little evidence of kings or rulers in Harappan society, but there must have been some form of civic organization that directed construction, water management, and trade. When the climate strained food systems, the social cohesion that held cities together began to fragment. By 1900 BCE, many of the largest Harappan cities were abandoned or dramatically depopulated. The once impressive granaries fell silent. The streets that once bustled with traders and families grew empty. Mohenjo-Daro, with its great bath, orderly streets, and advanced sewage system, gradually succumbed to neglect. The people did not vanish suddenly or violently. Instead, the civilization dispersed quietly. Its decline stretched across generations. Climate had not struck with one catastrophic blow, but rather carved away at the foundations of society, until those foundations could no longer support its weight. The Harappans survived, but their urban world did not.
The pattern of slow erosion, climate applying pressure until societal threads unravel, is repeated across history, and nowhere is this more evident than in the ancient Near East during the Bronze Age collapse. Around 1200 BCE, the interconnected world of the Eastern Mediterranean was thriving. Empires such as the Hittites, Egyptians, Mycenaeans, and Assyrians shared a network of trade and diplomacy that spanned lands and seas. Goods like tin, copper, grain, and textiles traveled through ports and caravan routes. Writing systems preserved political agreements, myths, and histories. Cities rose with fortifications, palaces, and temples dedicated to gods who supposedly watched over human affairs.
But beneath this flourishing surface, the climate was shifting once again. A powerful and prolonged drought struck the region during the Late Bronze Age. Tree ring data, sediment records, and archaeological evidence point toward a period of significant drying that lasted more than a century. As rainfall declined, harvests deteriorated. Grain shortages became common. Cities that depended on imported food faced starvation. Political tensions rose as nations accused each other of withholding crucial supplies. Letters found in the archives of Ugarit show desperate pleas for grain shipments from neighboring states. One ruler wrote, "If you do not send the grain, we will all die." These were not mere diplomatic exchanges, they were documents of impending collapse. Climate stress was only one factor, but it amplified every existing vulnerability. The drought weakened armies, making cities susceptible to invasions. It encouraged migrations of people seeking fertile land and water. Among them were groups later referred to as the Sea Peoples, seafaring tribes whose movements reshaped the political map of the Mediterranean. Some scholars argue that these groups were themselves displaced by famine and environmental decline in their homelands. As cities burned and empires crumbled, the Bronze Age network unraveled. The fall of the Hittite Empire, the destruction of Mycenaean palaces, the decline of Ugarit, and the weakening of Egypt's power all occurred during this tumultuous era. Inscriptions from Egypt describe invasions, famine, and the strain of defending borders against desperate outsiders. Ramses III, who fought major battles against the Sea Peoples, recorded that the foreign countries made a conspiracy in their islands. All at once, the lands were removed and scattered in the fray. Though written in the language of victory, these inscriptions reflect the fragility of even great powers under climatic pressure. The drought did not choose sides. It weakened all, and in that weakened state, societies that had relied on stability could no longer maintain their structures.
Far from the Mediterranean, on the edges of the Sahara Desert, another civilization faced climate's harshest tests. The Kingdom of Ghana, one of West Africa's earliest major states, developed around the 4th century CE. It thrived on trans-Saharan trade, especially in gold and salt. Caravans of camels crossed vast sands, carrying goods, culture, and ideas between West Africa and the Mediterranean. The region was not always as arid as today. Periods of increased rainfall allowed agriculture and pastoralism to flourish around the edges of the desert. But by the 11th century, a period of prolonged aridification set in. The Sahara expanded and desertification crept southward. Fields that once supported millet and sorghum turned to dust. Pasture lands for livestock dwindled. The camel caravans struggled as oases shrank and water sources dried. Environmental stress weakened the kingdom's economic foundation, making it vulnerable to external pressures. The Almoravids, a North African Berber dynasty, invaded in the late 11th century, further destabilizing the political structure. While the invasion played a significant role in Ghana's decline, climate change set the stage for fragility. As trade routes shifted and agricultural productivity fell, the kingdom gradually dissolved into smaller chiefdoms. Once again, climate did not act alone, but it acted decisively. On the other side of the world, in the Andes, the Tiwanaku civilization rose around Lake Titicaca in present-day Bolivia. Its engineers built raised fields, ingenious agricultural platforms surrounded by canals that moderated temperature and created microclimates suitable for crops. For centuries, this allowed Tiwanaku to thrive despite the harsh altitude. But around the 11th century CE, a severe and prolonged drought gripped the region. Lake Titicaca's water levels dropped dramatically. The raised field system became ineffective. As food production declined, political and social cohesion fractured. Tiwanaku, once a powerful Andean state, collapsed, leaving behind monumental stone structures that still stand as witnesses to the devastation of climate.
These stories, spread across continents and centuries, follow a similar arc. Societies rise in times of climatic stability and decline when environmental conditions shift dramatically. Yet what makes each story unique is how the people responded, whether with adaptation, innovation, migration, or collapse. One of the most striking examples of adaptation can be found in ancient Egypt during the Middle Kingdom. After a period of chaos during the First Intermediate Period, much of it exacerbated by low Nile floods, Egyptians reorganized, strengthened state control, and developed better water management techniques. They built canals, improved irrigation, and diversified their food storage systems. When droughts returned centuries later, these innovations allowed Egypt to endure longer than many neighboring societies. Though not immune to collapse, Egypt showed that proactive resource management could buffer the impacts of climate. Similarly, in the Andean region, the Inca Empire engineered agricultural terraces that allowed cultivation across steep mountain slopes. They created vast networks of storage facilities called colcas, where they kept food for years of scarcity. Their road systems ensured that surplus from one region could be transported to another. Though the Incas ultimately fell to Spanish conquest, their resilience against climate variability remains one of history's most remarkable achievements.
Yet, resilience does not guarantee survival. The Maya, for instance, built extensive reservoirs and terraced fields in the rainforest. Their rulers kept detailed astronomical records to track seasonal changes. Their cities were connected by road systems that facilitated trade and communication. But from the 8th to 10th century CE, a series of mega-droughts struck the region. Rainfall declined sharply, reservoirs dried, crops failed. Population centers became unsustainable. Warfare increased as city-states competed for dwindling resources. Eventually, many major Maya cities in the southern lowlands were abandoned. The collapse was not sudden, but spread across decades and centuries, varying by region. Maya culture survived, but the political structure that built the great cities fell apart. Climate shifts even influenced the fate of societies in the distant Pacific. On Easter Island, or Rapa Nui, the Polynesian settlers developed a complex culture known for its iconic moai statues. For centuries, the island supported a thriving population. But environmental pressures, including deforestation and soil erosion, combined with climatic variability such as cooling periods associated with the Little Ice Age. As resources dwindled, societal conflict erupted, contributing to population decline. The island story is often oversimplified, but it still illustrates the delicate balance between human activity and environmental limits. Climate has always shaped migration. One of the largest movements in history, the Bantu expansion across sub-Saharan Africa, was influenced in part by climate. As wetter periods created fertile lands in Central and Southern Africa, Bantu-speaking farmers moved into new territories, spreading agriculture, ironworking, and language. Conversely, when drought struck, migrations intensified, leading to cultural interchange and sometimes conflict with existing groups. Climate did not dictate the entire trajectory, but it created the environmental conditions that made large-scale migration both necessary and possible. The Vikings offer yet another example of how climate can shape cultural expansion and retreat. During the medieval warm period, milder temperatures allowed Norse sailors to explore and settle regions like Iceland, Greenland, and even parts of North America. But when the Little Ice Age began, harsher winters and shorter growing seasons made life in Greenland increasingly untenable. Pastures shrank under the cold, sea ice limited trade and communication with Europe. The Norse settlements eventually disappeared, leaving archaeological traces of abandoned farms and churches. Meanwhile, the Inuit, using technologies adapted to cold environments, flourished in the same conditions. Climate did not eliminate habitation, it eliminated inflexibility. In every region,
the same lesson emerges. Societies that rigidly depend on specific environmental conditions face the greatest risk when climate changes. Those that diversify, innovate, or adapt culturally can survive even profound environmental transformations. Human ingenuity is powerful, but it must be matched with humility before nature's unpredictability.
As human civilization entered the medieval era, climate continued to play its subtle yet decisive role in shaping societies across the world. Empires rose and fell, kingdoms expanded and fractured, trade networks flourished and crumbled, all under the silent but powerful influence of shifting temperatures, unpredictable storms, and changing rainfall. Unlike earlier eras, and climate shifts often triggered the collapse of sparsely documented civilizations, the medieval world left behind extensive written records. Chronicles, letters, tax registers, and monastic reports all preserved the struggles of communities confronted by environmental challenges that were larger than politics, religion, or ambition. Above all, this era was marked by two large climatic phases: the medieval warm period and the Little Ice Age. These contrasting epochs reshaped human destiny with their alternating gifts and punishments, reminding societies that climate could bestow prosperity as easily as it could bring ruin. The medieval warm period, roughly spanning 950 to 1250 CE, was a time of mild temperatures in many parts of the northern hemisphere. Fields in Europe produced abundant harvests. Growing seasons lengthened. Forests retreated slightly as farmers expanded their lands. Vineyards reached regions previously too cold for grape cultivation. The population of Europe surged, and with it came urbanization, trade, and cultural transformation. The warmth of the period enabled agricultural innovation. Peasants adopted the heavy plow, which cut through rich but dense northern soils. Three-field crop rotation increased yields, allowing more food to be produced with the same amount of land. Market towns grew around trade routes, while monasteries accumulated land and wealth through improved farming. Yet the benefits of this warm period were not distributed equally across the world. In some regions, such as parts of Central Asia, the warmth contributed to drought. Steppe lands dried, affecting pastoral nomads whose herds required extensive grazing areas. Scholars believe that environmental shifts during this era contributed to migrations and conflicts among nomadic groups. As grazing land diminished, tribes competed for territory. These internal pressures may have played a role in the rise of powerful leaders like Genghis Khan, whose unification of the Mongol tribes unleashed a wave of expansion that transformed Eurasia. Climate did not create the Mongol Empire, but it shaped the conditions that allowed it to emerge. The grasslands of Mongolia experienced alternating periods of drought and abundance, and each shift influenced the mobility and military strength of nomadic armies. The Mongol expansions themselves reshaped landscapes. Cities destroyed in Central Asia and Persia were left in ruins, their irrigation systems disrupted, and their farmlands abandoned. Some regions never fully recovered. But climate was an underlying factor in the initial unrest that united the steppe under a single banner. The empire's expansion intersected with environmental variability in ways that intensified its impact. Trade routes like the Silk Road flourished under Mongol rule, but were vulnerable to climatic fluctuation. When rainfall decreased, some caravan routes became difficult to traverse, requiring traders to take longer, riskier paths. While the Mongols reshaped the East, Europe thrived under favorable weather. Yet the seeds of future crisis were already planted. As populations grew, societies expanded into marginal lands, forests, marshes, and hillsides that were productive only under ideal climatic conditions. These lands offered temporary prosperity, but they were vulnerable to even slight changes in temperature or rainfall. Throughout the 12th and 13th centuries, Europe's prosperity seemed unshakable. Cathedrals rose in stone and glass. Universities emerged. Trade networks linked cities across the continent. Towns grew dense, filled with markets, guilds, and artisans. But all of this rested on the single most fragile foundation: food security. Then, around the early 14th century, the climate began to shift. The medieval warm period faded, and a colder, harsher era gradually took hold. The Little Ice Age, which would last into the 19th century, arrived not with a single dramatic event, but with subtle changes that collectively reshaped societies. Winters grew longer and more severe. Summers shortened. Rainfall patterns changed, producing wet, cold summers that were disastrous for grain crops. Rivers froze deeper and longer than before. Glaciers advanced in mountain regions, swallowing farmland and villages. Storms intensified. The North Atlantic experienced colder currents, contributing to more frequent and violent tempests. These changes strained the agricultural systems upon which medieval Europe depended. One of the first major crises triggered by the onset of the Little Ice Age was the Great Famine of 1315 to 1317. A series of unusually cold and wet summers made it nearly impossible for grain to ripen. Torrential rains flooded fields and rotted crops. Livestock died from disease and lack of fodder. Food reserves quickly ran out, since medieval societies rarely stored large surpluses. Starvation spread rapidly across northern Europe. Chroniclers wrote of people eating cats, dogs, and even grass. Some accounts describe parents abandoning their children or resorting to cannibalism. Whether literal or exaggerated, these accounts reflect the desperation of the time. The famine weakened populations, making them susceptible to disease. Malnutrition eroded immune systems, rendering people vulnerable to infections that might otherwise have been survivable. And so, when the Black Death arrived in the 1340s, it encountered a population already pushed to the edge by environmental stress. The plague killed tens of millions across Europe, the Middle East, and Asia. The death toll was catastrophic, reshaping economies, societies, and political structures. Climate did not cause the plague, but it prepared the conditions that allowed it to devastate the world. The weakened harvests, famine-driven migrations, and growing urban crowding created environments ideal for the spread of disease.
As the Little Ice Age deepened, Europe struggled to adapt. Some regions responded with innovation. The Dutch, faced with rising sea levels and storm surges, built dikes and reclaimed land through engineering that was centuries ahead of its time. Their resilience became a model for environmental adaptation. In mountainous regions, communities constructed terraces and improved storage methods for grain and cheese. Meanwhile, in Scandinavia, harsher winters made farming more difficult. Many communities turned to fishing, trade, and crafts. Yet even these adaptive strategies could not prevent periods of crisis. The 17th century witnessed one of the coldest phases of the Little Ice Age. Artists of the period often painted frozen rivers, snow-covered villages, and icy landscapes. But behind the picturesque imagery lay deeper social consequences. In France, years of poor harvests contributed to economic hardship, fueling social unrest that sometimes erupted into rebellion. In Russia, the time of troubles, a period of political upheaval and famine in the early 1600s, was exacerbated by climate. The failed harvest of 1601 to 1603, linked to volcanic activity and cooling, killed hundreds of thousands.
Droughts and cold spells weakened states, creating openings for invasions or internal conflict. Climate even influenced the outcomes of major political events. In the English Civil War, poor harvests and cold winters added pressure to an already divided society. In China, the Ming Dynasty faced repeated climatic shocks during its final century. The late Ming period suffered from droughts, floods, and unusually cold temperatures. The failure of harvests weakened the economy, contributed to peasant rebellions, and undermined state authority. When the Qing dynasty rose to power, it did so in a landscape shaped by environmental stress. Beyond Europe and Asia, the Little Ice Age had profound effects on indigenous peoples in North America. Many societies relied on predictable seasonal cycles for agriculture, hunting, and fishing. When climate variability increased, it forced migrations, altered traditional food sources, and contributed to cultural transformations. The ancestral Puebloans in the American Southwest had already abandoned some settlements centuries earlier due to drought. In the Northeast, the Iroquois Confederacy rose in a period marked by changing environmental patterns that influenced food storage practices and political alliances. The world was interconnected not through global trade as we know it today, but through the shared experience of climate. Every region adapted or suffered according to its environmental resources and political stability. Yet despite widespread hardship, the Little Ice Age also stimulated innovation. Fisheries expanded in colder waters. New crops like potatoes and maize, brought from the Americas, spread across Europe and Asia, diversifying diets and increasing resilience. The introduction of these crops, especially the potato, allowed populations to grow despite challenging weather. Maize provided nourishment in regions where traditional grains faltered.
In the early modern era, climate influenced exploration and empire building. Harsh winters and unpredictable winds made sea voyages risky, but European nations persisted. The search for new resources, driven partly by environmental stress at home, pushed explorers across the oceans. Climate shaped the success or failure of colonial ventures. In North America, the starving time at Jamestown during the early 1600s was worsened by drought revealed in tree ring records. The colony struggled to survive as crops failed and relations with indigenous peoples deteriorated under resource stress. Meanwhile, the expansion of European empires dramatically altered ecosystems worldwide. Colonization introduced new crops, animals, and diseases into fragile environments. Forests were cleared for plantations, wetlands were drained. Indigenous agricultural systems, often adapted to local climatic conditions over centuries, were disrupted or replaced. Climate now interacted with human-driven environmental changes on a scale unprecedented in history. Colonizers built economies that depended on large-scale extraction of land and resources, creating vulnerabilities that would become apparent centuries later. Back in Europe, the Little Ice Age reached its peak in the 17th century. The Thames in London froze thick enough to support winter markets known as frost fairs. People skated across rivers in the Netherlands that rarely froze so solidly today. In Germany, vineyards struggled. Wine production, once a symbol of medieval abundance, declined in colder regions, forcing farmers to adapt or abandon traditional crops. In Scandinavia, storms battered coastlines, sinking ships and reshaping trade routes. Climate also intervened in warfare. The defeat of the Spanish Armada in 1588, often credited to English naval strategy, was aided in part by severe storms that scattered the Spanish fleet. Similarly, the Swedish invasion of Russia in 1708 to 1709 under Charles XII failed partly due to one of the harshest winters on record. Soldiers froze in their camps, horses died in the snow, and supply lines collapsed. Climate did not determine victory or defeat, but its influence was undeniable. An army could be strong, but not stronger than the weather. The Little Ice Age reshaped not only politics and warfare, but also culture. Artists depicted winter scenes with fascination. Writers commented on the unpredictability of seasons. Communities developed winter festivals, rituals, and traditions in response to the colder climate. Folk tales and superstitions evolved, often linking strange weather to omens or divine displeasure. Climate left its imprint on the imagination as well as on the physical world. By the 18th century, gradual warming began, though the Little Ice Age would not fully end until the mid-19th century. Industrialization emerged during this transitional period, bringing new tools to confront environmental challenges and creating new ones. Coal-fed factories filled the air with smoke. Urbanization intensified pollution and reshaped landscapes. Human activity now influenced climate in ways no previous civilization had ever achieved. The balance between humanity and the natural environment shifted dramatically, setting the stage for the modern era and its unprecedented ecological transformations.
The world entered the late medieval centuries with a curious sense of momentum. Populations were growing in Europe, trade routes were expanding across Asia, and agricultural yields stood at the highest level since antiquity, thanks to relatively mild and stable weather during the medieval warm period. Yet, in a transformation that unfolded quietly at first, the climate's long-term rhythms began shifting once again. The warmth that had sustained medieval societies started to fade. Glaciers began inching forward in the Alps. Seasons grew unpredictable. Harvests that once felt secure became precariously dependent on the whims of volatile skies. What followed was one of the most dramatic climatic downturns of the last millennium. The Little Ice Age, a centuries-long cooling that reshaped economies, altered political destinies, and tested the resilience of societies from Europe to the Americas to Asia. Part 4 explores how this global cold spell did not merely inconvenience people, it upended civilizations, catalyzed revolutions, inspired migrations, and forged new cultural landscapes that still echo in our world today. To understand the Little Ice Age, one must first appreciate its complexity, for it was not a single event, but a cluster of climatic trends punctuated by acute disruptions. Scientists identify several causes: decreased solar activity, such as the Maunder Minimum, heightened volcanic activity that injected sunlight-blocking aerosols into the atmosphere, and feedback loops in ocean currents that redistributed heat unevenly. Although the cooling was not uniform everywhere, the general pattern was unmistakable. Winters grew harsher, summers shorter, and climatic extremes more frequent. In some decades, sea ice creeped down toward lower latitudes. In others, monsoons faltered across Asia. These changes did not occur overnight, but societies absorbed their consequences with remarkable immediacy. Fields failed, rivers froze, livestock died, forests withered. And, as always, when the stability of nature wavered, the structures of human civilization trembled with it. Europe became one of the most thoroughly documented victims of Little Ice Age volatility. Beginning in the early 14th century, a sequence of poor harvests triggered what became known as the Great Famine of 1315 to 1317. Torrential rains soaked fields across northern Europe, turning arable land into mud and rotting crops in the soil. Livestock succumbed to disease as fodder spoiled, and starving peasants ate whatever they could find, from bark and grass to the bodies of animals that had long been considered inedible. Chroniclers describe scenes of hunger so severe that entire villages were abandoned. Governments struggled to respond. Markets collapsed. Food prices shot upward. And in many regions, social order dissolved as desperate populations protested, fled, or succumbed to illness and starvation. The Great Famine was not merely a humanitarian tragedy. It marked a fundamental turning point in medieval Europe's demographic and economic trajectory.
But perhaps the most famous catastrophe associated with this period was the Black Death, which struck Europe in the mid-14th century. While the plague itself was caused by a bacteria, its spread was amplified by the environmental stresses of the early Little Ice Age. Malnutrition weakened immune systems. Trade disruptions created pockets of instability where disease could flourish. Rats, fleeing from colder climates, moved into human settlements. Moreover, fluctuating weather patterns influenced rodent populations in Central Asia, where the plague originated. The pandemic swept across continents with terrifying speed, killing an estimated 1/3 to 1/2 of Europe's population and significant portions of Asia and the Middle East. Though climate was not the root cause of the plague, it formed part of an interconnected web of stressors that made societies vulnerable to biological disaster.
As the centuries progressed, Europe continued facing climatic swings that tested its endurance. Rivers that had never frozen before became temporary highways of ice. The Thames River in London hosted frost fairs, complete with markets, games, and temporary inns constructed directly atop its frozen surface. These frost fairs were celebrated in art and literature, but they masked the grim reality that such freezing indicated widespread agricultural hardship and the destabilization of trade routes. In alpine regions, glaciers advanced relentlessly, swallowing farms and even entire towns. In Scandinavia, repeated crop failures pushed communities into poverty and violence. And across the continent, colder weather shortened the growing season, slashing yields of wheat, rye, and barley, staples that had long sustained populations. Bread prices soared, fueling peasant uprisings and urban riots that destabilized both monarchies and emerging commercial economies. Yet Europe was not the only region transformed by the Little Ice Age. In North America, indigenous populations who had built thriving agricultural centers also confronted dramatic environmental pressures. The ancestral Puebloans of the American Southwest, who had already experienced earlier drought cycles, faced renewed climatic instability. Crops such as maize became increasingly difficult to cultivate as summers cooled and rainfall became erratic. Communities adapted through migration, repositioning of settlements, or switching subsistence strategies, but not without significant social upheaval. In the eastern woodlands, cooling trends altered forest compositions and wildlife patterns, influencing hunting practices and reshaping intertribal dynamics. The Inuit peoples of the Arctic excelled in adapting to harsher conditions, developing improved hunting technologies and navigational methods that allowed them to survive even as sea ice expanded and marine ecosystems shifted. South America felt the strain too. The mighty Inca Empire, resting across the Andes Mountains, experienced fluctuations in rainfall that disrupted the sophisticated terraced agricultural systems that had made high-altitude farming possible. Glacial meltwater, essential for irrigation, became less reliable as glaciers advanced into valleys or receded unevenly, resulting in alternating periods of flooding and drought. The empire's political structure, already strained by internal rivalries, was further weakened by these environmental hardships. When Spanish conquistadors arrived in the 16th century, the Inca were dealing with a combination of climatic pressures and epidemics introduced by Europeans. The Little Ice Age did not destroy the Inca, but it amplified their vulnerabilities at a critical moment in history.
Japan experienced its own climate-driven upheavals. Colder temperatures caused repeated crop failures, especially affecting rice, the backbone of Japanese society and taxation. The Great Tenmei Famine of the 1780s, for instance, was triggered in part by a volcanic eruption in Iceland that caused global cooling and dimmed sunlight for months. In Japan, the resulting agricultural collapse killed hundreds of thousands and destabilized the social structure of the Tokugawa shogunate. These chronic famines fueled rural rebellions, reshaped trade patterns, and pressured authorities to reform agricultural policies and taxation systems. Here again, climate acted not as a singular force of destruction, but as an accelerating factor that exposed pre-existing structural weaknesses. Even Africa felt the far-reaching effects of the Little Ice Age. Across the Sahel, the boundary between the Sahara Desert and the savanna shifted southward, constraining grazing lands and altering migration patterns. Communities that once practiced mixed farming and herding found their livelihoods threatened. In Ethiopia, highland rainfall became erratic, contributing to cycles of famine. In parts of West Africa, cooling temperatures altered the dynamics of diseases like malaria, affecting populations and trade networks. And in the southern regions of the continent, shifts in rainfall impacted agricultural societies, such as the Zulu and Kusa, influencing their political consolidation and interactions with European colonizers. Though the environmental data for Africa during this period is still being refined, the patterns strongly suggest that the Little Ice Age helped reconfigure social and political developments across the continent. Meanwhile, the colder climate played a surprising role in one of history's most iconic chapters, the European Age of Exploration. With agricultural yields declining and trade routes becoming less reliable, European states sought new resources and commercial opportunities abroad. Economic pressures pushed maritime innovation, prompting nations like Portugal, Spain, England, and the Netherlands to venture into the Atlantic and beyond. The search for spices, gold, and labor was motivated not only by ambition, but by necessity, as the environmental stresses of the Little Ice Age squeezed domestic economies. In this sense, the global reshaping of human societies was not merely reactive, but also exploratory, catalyzing migrations, conquests, and cultural exchanges on an unprecedented scale. The Little Ice Age even influenced military history. In Russia, freezing winters helped repel invading armies, most famously Napoleon's disastrous 1812 campaign. His troops, unprepared for the extreme cold, suffered catastrophic losses, an outcome shaped not only by strategic failures, but by climatic realities. Similarly, in the Balkans and Eastern Europe, harsh winters slowed military campaigns and disrupted supply lines. Climate did not determine the outcome of every conflict, but it often tipped the balance by imposing conditions that armies could not overcome.
Culturally, the Little Ice Age left a profound mark. Artists across Europe captured scenes of frozen rivers, snow-covered villages, and winter festivals. Painters such as Peter Bruegel the Elder immortalized the era's cold in works that depict both the beauty and hardship of winter landscapes. Literature also reflected the anxieties of the age, with themes of divine punishment, cosmic instability, and social fragility permeating the writings of the period. Scientific curiosity grew as scholars attempted to understand the natural forces behind the unpredictable weather. These efforts laid the groundwork for early climatology and contributed to a broader shift in how humans conceptualized their relationship with the environment. Yet, even amid widespread hardship, people adapted in ingenious ways. Farmers experimented with new crop rotations and hardier grains. Communities developed improved storage techniques, building granaries that could withstand longer winters. Merchants diversified trade networks to reduce dependency on single regions or harvest cycles. Governments introduced relief policies, some rudimentary by modern standards, but innovative for their time. Across the world, societies responded with resilience, although not always with equal success. One of the most compelling lessons from the Little Ice Age is how environmental stress can magnify existing vulnerabilities.
Societies with rigid political systems or brittle economic structures tended to suffer more severely than those with flexible governance or diverse subsistence strategies. The Ming Dynasty, for instance, maintained a highly centralized bureaucracy that struggled to respond quickly to local crises. European feudal systems, reliant on fixed obligations and agrarian surpluses, faltered when those surpluses vanished. In contrast, some indigenous communities in the Americas demonstrated adaptability by shifting settlement patterns or diversifying food sources. Resilience depended as much on social organization as on geography. As the Little Ice Age shifted toward its conclusion in the 19th century, temperatures gradually began rising, setting the stage for the modern era. The end of the cold spell coincided with the dawn of industrialization, which introduced new energy systems, technologies, and economic structures. Ironically, the innovations that helped societies recover from centuries of climatic instability would later contribute to anthropogenic climate change, reshaping the planet in unprecedented ways. Looking back, the Little Ice Age serves as a remarkable example of how climate can act as a silent force in human history, subtle yet powerful, invisible yet transformative. It did not destroy civilizations outright, but it nudged, pressured, and reshaped them in ways that redefined the global historical trajectory. It demonstrated the interconnectedness of environmental systems and human societies, illustrating how even slight shifts in temperature or rainfall can ripple through economies, political institutions, and cultural identities. The story of the Little Ice Age also reveals the importance of adaptation. Societies that embraced flexibility, innovation, and cooperation tended to endure or even thrive despite climatic shocks. Those that clung to rigid structures, ignored warning signs, or exploited natural resources unsustainably found themselves overwhelmed when the environment turned against them. These lessons echo loudly today as the modern world confronts its own environmental crises.
When the 19th century dawned, the world was emerging from the long shadow of the Little Ice Age. Winters were slowly becoming milder, summers slightly warmer, and global temperatures edging upward after centuries of irregular climactic rhythms. In earlier epochs, shifts in climate had been driven by the great cycles of the planet: orbital variations, volcanic eruptions, solar fluctuations, and the slow dance of ocean currents. But as this new era unfolded, something unprecedented occurred. For the first time in Earth's history, an animal species, humankind, began altering the planet's climate in ways that no natural force alone had ever accomplished. The rise of industrialization marked not just an economic transformation, but a climatological turning point, one whose consequences continued to reverberate through every level of society today. To understand this momentous shift, we must step into the cold, darkened streets of early industrial Britain, where the first signs of a new...
When the 19th century dawned, the world was emerging from the long shadow of the Little Ice Age. Winters were slowly becoming milder, summers slightly warmer, and global temperatures edging upward after centuries of irregular climatic rhythms. In earlier epochs, shifts in climate had been driven by the great cycles of the planet: orbital variations, volcanic eruptions, solar fluctuations, and the slow dance of ocean currents. But as this new era unfolded, something unprecedented occurred. For the first time in Earth's history, an animal species, humankind, began altering the planet's climate in ways that no natural force alone had ever accomplished. The rise of industrialization marked not just an economic transformation, but a climatological turning point, one whose consequences continue to reverberate through every level of society today. To understand this momentous shift, we must step into the cold, darkened streets of early industrial Britain, where the first signs of a new climate regime appeared, not in glaciers or in oceans, but in the air above cities transformed by factories. As steam engines roared and soot billowed from towering chimneys, the skies above London, Manchester, and Birmingham turned a permanent gray. Smoke hung low over rooftops, mixing with fog in a phenomenon that locals came to call smog, a poisonous blend of soot, sulfur, and moisture that could choke lungs and obscure the sun. The Industrial Revolution was spreading, fueled by coal, ambition, and a relentless drive to mechanize production. Yet few at the time recognized that the true revolution was not the factory machines themselves, but the greenhouse gases that streamed invisibly from their furnaces and furnaces around the world. Coal was the beating heart of industrialization. Before the 19th century, humanity relied largely on wood, charcoal, wind, and water for energy. These sources were limited, localized, and relatively low in carbon emissions. Coal, however, was different. It burned hot, burned long, and burned in vast quantities. It powered steam engines, locomotives, iron smelters, textile mills, and eventually entire electrical grids. By the mid-19th century, coal consumption in Britain had reached staggering levels. Cities expanded rapidly, population surged, and the mechanized economy reshaped social structures. But along with these transformations came an explosion of carbon dioxide emissions that began accumulating in the atmosphere, initiating a trend that scientists would only understand generations later. The global consequences of industrialization were not immediate in the way that volcanic eruptions or severe droughts had been, but they were profound. Carbon dioxide is a subtle agent of change. It traps heat by absorbing infrared radiation, enhancing the natural greenhouse effect that keeps Earth warm enough to sustain life. In small amounts, it is essential, but as concentrations rise, the balance of the planet's energy budget shifts. Temperatures creep upward. Weather patterns begin to shift. Oceans absorb more heat and more carbon, altering their chemistry. These changes unfold over decades or centuries, often eluding direct observation, yet steadily reshaping the world.
Early observers did not fully grasp this. The Industrial Age was a time of extraordinary optimism regarding human mastery over nature. Steamships crossed oceans in weeks instead of months. Railroads stitched continents together. Telegraph lines pulsed with electrical signals, collapsing distances between cities and nations. Factories multiplied, producing textiles, iron, and manufactured goods that flooded global markets. Urban populations ballooned. For many, these changes represented progress, tangible evidence that humanity was conquering the limitations that had bound earlier generations. But beneath the enthusiasm lay emerging signs of stress. The very fossil fuels that powered industrial civilization began degrading the environment around the communities that depended on them. In London, coal pollution caused respiratory diseases, corroded buildings, and blackened the stone facades of historic landmarks. Waterways became dumping grounds for industrial waste. Rivers such as the Thames, Seine, and Ruhr were rendered toxic, stripped of fish, and choked by chemical runoff. Forests were felled at alarming rates to make way for mining operations, urban expansion, and rail networks.
In the United States, the once vast forests of the East were harvested to feed burgeoning industrial demands before exploitation shifted westward. The bison herds of the Great Plains, numbering tens of millions, were slaughtered to near extinction as railroads and agricultural expansion accelerated. Still, the climatic implications of industrialization remained mostly invisible. The world seemed too vast, the atmosphere too expansive for human activity to alter them meaningfully. It was not until the late 19th century that scientists began piecing together the first clues. In 1856, Eunice Newton Foote, an American scientist, conducted experiments demonstrating that carbon dioxide could trap heat within glass cylinders. Her work suggested that increases in atmospheric CO2 could warm the planet, a groundbreaking insight that received too little recognition at the time. A few decades later, the Swedish chemist Svante Arrhenius calculated that doubling atmospheric CO2 could significantly raise global temperatures, an idea that his contemporaries dismissed as theoretical speculation. Nevertheless, these early studies planted the seeds of climate science. Yet climate change remained largely absent from public consciousness throughout the 19th century. More immediate disasters drew attention instead. One of the most devastating episodes illustrating the intersection of climate and industrial society occurred in India during the 1876-1878 famine. Triggered by a strong El Niño event that disrupted monsoons, the drought led to catastrophic harvest failures across southern India. Mortality rose to horrific levels as colonial policies intensified rather than alleviate the crisis. British authorities, committed to free market ideology and reluctant to intervene in grain markets, allowed shipments of food to continue out of India even as millions starved. Climatic shock collided with political rigidity and imperial exploitation, producing one of the deadliest famines in modern history, and offering a stark reminder that environmental disasters are often magnified by social structures.
In China, droughts and floods intensified during the late Qing dynasty, contributing to uprisings such as the Taiping Rebellion and Boxer Rebellion. The environmental stresses placed upon the empire exacerbated political instability, encouraging widespread dissatisfaction with the ruling elite. In Africa, shifting rainfall patterns and locust outbreaks disrupted agricultural communities already reeling from colonial interference and the slave trade. In the American West, drought cycles influenced migration patterns, settlement expansions, and conflicts between settlers and indigenous peoples. The Dust Bowl of the 1930s, though occurring later, reflected both climatic variability and unsustainable farming practices that stripped the Great Plains of its protective grasses. Throughout the industrial era, environmental shocks intersected with human decisions in ways that revealed how fragile even modern societies could be when confronted with climate change. As global industrialization accelerated in the 20th century, fossil fuel use expanded exponentially. The internal combustion engine transformed transportation. Coal-fired power plants electrified cities. Oil emerged as a critical resource, fueling automobiles, airplanes, ships, and tanks. Natural gas joined coal and oil as a major energy source. Each advance deepened humanity's dependence on carbon-rich fuels. The United States, Europe, Japan, and later China and India built economies that thrived on the combustion of fossil energy. With this growth came prosperity, technological breakthroughs, longer life expectancies, and unprecedented global interconnectedness. Yet beneath these achievements lay an invisible accumulation of atmospheric carbon that grew year by year, decade by decade. By the mid-20th century, scientists began noticing measurable increases in CO2 concentrations. In 1958, Charles David Keeling initiated a monitoring program at Mauna Loa Observatory in Hawaii that produced one of the most important scientific graphs in history, the Keeling curve.
It showed a steady, upward trajectory of atmospheric CO2, with seasonal fluctuations but an unmistakable long-term rise. This curve provided empirical evidence that the burning of fossil fuels was altering the atmosphere in real time. At first, public reaction was muted. Many saw climate as stable and unchanging, but the implications of the data were profound. Humanity had become a geological force. The Cold War further accelerated this transformation. Industrial production surged as nations competed for military dominance. Nuclear power emerged as a promising, if controversial, alternative energy source, but fossil fuels remained the backbone of global economies. Suburbanization fueled car culture, especially in the United States, where highways replaced streetcars and urban sprawl expanded outward from city centers. Petroleum became the lifeblood of industrial societies, driving everything from agriculture, which now relied heavily on mechanized farming, to global shipping networks that transported goods across oceans. During the latter half of the 20th century, climate signals became harder to ignore. The 1970s brought severe droughts in Africa's Sahel region, leading to famine and mass migration. Dust storms swept across the region, driven by overgrazing, poor land management, and shifts in atmospheric circulation that reduced rainfall. Scientists began linking these changes to broader climatic patterns influenced by human activity. Meanwhile, extreme weather events elsewhere, heat waves, floods, storms, sparked discussions about the possibility of a changing climate. In 1988, the Intergovernmental Panel on Climate Change, IPCC, was established, marking the first coordinated global effort to understand and address climate change. Scientific consensus grew stronger as data accumulated from ice cores, ocean studies, atmospheric monitoring, and climate models. Researchers demonstrated that CO2 levels were higher than at any point in at least 800,000 years, and rising at a rate unmatched in geological history. The planet was warming, polar ice was melting, sea levels were rising, ecosystems were shifting. The climate of the industrial age was not simply changing, it was destabilizing. Yet even as scientific warnings became more urgent, political and economic systems struggled to adapt. Fossil fuel industries wielded immense influence, shaping public discourse and policy debates. Governments hesitated to limit emissions for fear of slowing economic growth. Consumers continued relying on carbon-intensive lifestyles: cars, airplanes, electronics, air conditioning, industrial agriculture, without recognizing the cumulative consequences. The problem was global, yet responsibility was unequal. Industrialized nations, having emitted the vast majority of historical CO2, were reluctant to bear the full burden of reducing emissions, while developing nations argued for their right to grow economically. Despite these challenges, the 20th century also witnessed remarkable environmental achievements. International agreements such as the Montreal Protocol succeeded in addressing the ozone crisis by phasing out chlorofluorocarbons, demonstrating that global cooperation on environmental issues was possible. Renewable energy technologies emerged: solar panels, wind turbines, geothermal power, offering glimpses of a post-fossil fuel future. Conservation efforts protected endangered species and restored degraded landscapes. Urban planners began designing greener cities, and climate activists, scientists, and youth movements helped raise awareness and push for systemic change. Still, as the century closed, the scale of the challenge became starkly clear. The industrial era had unleashed forces that would shape the climate for centuries to come. The planet was on a trajectory toward warming unlike anything in human history. The systems that underpinned modern civilization, food production, water security, energy infrastructure, coastal settlements, were built on assumptions of climatic stability, but that stability was eroding. The lessons of past crises, from the Maya drought to the Little Ice Age, suggested that societies that ignored environmental threats risked collapse. Industrial-era societies now faced a similar dilemma, but at a global scale. The next century would test humanity's capacity for foresight, cooperation, and resilience. Would the world respond with adaptation, innovation, and responsibility? Or would it repeat the pattern seen so many times before, where environmental warnings were ignored until catastrophes forced change? Those questions lead us toward the final section, the era of accelerating climate change, where the warming planet confronts modern civilization with unprecedented challenges, and where lessons from history become more relevant than ever.
The 21st century began with a sense of extraordinary promise. Technology advanced at a pace unmatched in human history. Satellites circled the Earth, offering real-time images of storms, forests, oceans, and melting ice caps. Medical breakthroughs lengthened lifespans. Global communications knit cultures together in ways unimaginable to earlier generations. Yet beneath this rapid progress lay a deepening vulnerability, one forged by 2 centuries of industrial expansion and the invisible accumulation of greenhouse gases in the atmosphere. The climate that had nurtured agriculture, supported social stability, and framed every chapter of human civilization was now shifting so rapidly that it threatened to reshape the world once more. Part 6 examines the unfolding crisis of modern climate change, the fragility it exposes in our global systems, and the choices that may determine humanity's future. For thousands of years, humanity lived within a climatic envelope known as the Holocene, a relatively stable epoch marked by mild temperatures and predictable seasons. This stability provided the foundation for agriculture, urbanization, and the long rise of civilization. But as the 20th century drew to a close, scientists began concluding that humanity had pushed the planet into a new era, an epoch shaped not by natural cycles but by human activity. Some called it the Anthropocene, a time when fossil fuels, industrial agriculture, plastic pollution, deforestation, and greenhouse gas emissions had become planetary forces rivaling volcanoes and orbital variations. The evidence was visible everywhere, in rising temperatures, melting ice sheets, changing ocean chemistry, and shifting weather patterns that echoed and often exceeded the climatic upheavals of earlier historical episodes. The early years of the new century were punctuated by a series of climatic signals that revealed the accelerating pace of change. Heat waves struck Europe in 2003, killing tens of thousands and overwhelming health systems. Scientists later identified that similar events would have been nearly impossible without human-caused warming. In the Arctic, sea ice retreated at alarming rates, opening navigable waters once locked in ice for millennia. Polar bears, whose habitats depended on stable ice platforms, struggled to find food. Indigenous Arctic communities saw hunting grounds vanish, coastlines erode, and traditional ways of life disrupted by warming twice as fast as the global average. Meanwhile, in the tropics, coral reefs, among the most biodiverse ecosystems on Earth, suffered mass bleaching events as ocean temperatures rose. In places like the Great Barrier Reef, entire stretches of coral died, collapsing the complex marine life they supported. The oceans themselves were undergoing transformations that would shape the future in profound ways. Absorbing nearly a third of human-emitted carbon dioxide, seawater became more acidic, weakening shell formation in marine organisms and altering food chains. Warmer waters fueled stronger hurricanes and cyclones, transforming storms into devastating disasters with little warning. In the Pacific, rising sea levels threatened the very existence of island nations such as Kiribati and Tuvalu, forcing leaders to contemplate relocation, an extraordinary burden that mirrored the climate migrations of earlier civilizations, but now unfolding on a global stage.
Meanwhile, extreme weather patterns intensified around the world. Floods ravaged Pakistan in 2010, submerging vast regions and displacing millions. Wildfires tore across Australia in 2009 and again in 2019 to 2020, burning forests that had not seen such intensity in recorded history. California, Greece, Turkey, and Siberia faced infernos that turned skies orange and filled cities with smoke. In the Amazon, deforestation combined with drought increased the risk of tipping points, thresholds beyond which ecosystems may not recover. The Amazon rainforest, long a stabilizing force in the global climate, seemed perilously close to becoming a net carbon emitter rather than a carbon sink, a shift with consequences that would ripple across continents. The global food system, which feeds billions, has proven especially vulnerable. Industrial agriculture depends on predictable weather, stable temperatures, and reliable water supplies, all of which are now under threat. Heat stress reduces crop yields of staples like wheat, rice, and maize. Droughts wither fields and dry up irrigation reservoirs. Storms destroy harvests and disrupt supply chains. In some regions, such as the Horn of Africa, recurrent droughts have intensified food insecurity and contributed to humanitarian crises. Across South Asia, shifting monsoons challenge farming communities that have depended on seasonal cycles for thousands of years. Meanwhile, melting glaciers in the Himalayas, critical sources of fresh water for more than 1 billion people, pose long-term threats as they retreat. Rivers dependent on glacial melt may swell in the short term, but could one day diminish, jeopardizing agriculture, industry, and drinking water supplies. The interplay between climate change and political instability has become increasingly clear. In Syria, prolonged drought from 2006 to 2010 devastated agricultural regions, forcing rural families to migrate to cities. Combined with political grievances, economic inequality, and government mismanagement, these pressures contributed to social unrest and a brutal civil war. Although climate change did not cause the conflict, it amplified existing tensions. Similar patterns emerged elsewhere. In the Sahel, where desertification and competition over shrinking resources fueled violence. In Central America, where crop failures contributed to migration toward the United States. And in Southeast Asia, where rising sea levels threaten megacities such as Jakarta, Manila, and Bangkok. History offers many examples of environmental pressures driving social upheaval. The Akkadians, the Maya, the Ming. But the modern era magnifies these risks across a planet of 8 billion people. Despite the mounting dangers, the 21st century has also seen unprecedented efforts to confront the crisis. The 2015 Paris Agreement marked a moment of global unity as nearly every nation pledged to reduce emissions and limit global warming. Renewable energy technologies expanded rapidly. Solar power, once expensive, became one of the cheapest sources of electricity in the world. Wind farms appeared across plains and coastlines. Electric vehicles gained momentum. Urban planners began designing greener, more resilient cities. Businesses incorporated sustainability into their models. Scientists refined climate models with increasing precision, helping governments plan for future impacts. These developments represented glimpses of hope, proof that societies could innovate and adapt on a global scale.
Yet, progress has been uneven. Emissions continue to rise in many countries as energy consumption increases. Fossil fuels remain deeply embedded in global infrastructure. Political polarization slows climate policy. Some governments retreat from international commitments, fearing economic repercussions or succumbing to short-term interests. Misinformation circulates widely, obscuring scientific consensus. Meanwhile, the world's poorest regions, which contribute least to global emissions, often bear the brunt of climate impacts. The inequities echo those of earlier eras, where environmental change disproportionately harmed those with fewer resources or political power. But the story of climate and humanity is not solely one of danger. It is also one of resilience, innovation, and the enduring capacity to adapt. Across the world, communities are developing strategies to live with a changing climate. Coastal cities build seawalls, restore wetlands, and redesign infrastructure to withstand rising seas. Farmers adopt drought-resistant crops and regenerative farming practices that restore soil health. Forests are being replanted, protected, or allowed to regrow naturally. Indigenous communities draw upon generations of ecological knowledge to steward ecosystems and advocate for sustainable governance. Scientists explore carbon capture, advanced nuclear power, and ecosystem restoration as means of mitigating emissions. And young people, recognizing the stakes of their future, lead global movements demanding action, accountability, and justice. Yet adaptation alone will not be enough. The climate system contains tipping points, thresholds beyond which changes become irreversible or self-reinforcing. The collapse of ice sheets in Greenland or Antarctica could trigger rapid sea level rise. The thawing of permafrost could release massive quantities of methane, accelerating warming. The destabilization of the Amazon could transform it into savanna. Ocean currents that regulate global climate might weaken or shift, altering weather patterns on a planetary scale. These tipping points resemble the climatic disruptions that toppled past civilizations, but with one crucial difference. Today's tipping points could unfold globally, affecting every nation, every economy, and every ecosystem. The choices humanity faces in the coming decades echoed the dilemmas of history's great collapses, but on a grander scale. Civilizations that survived environmental stress, like the ancient Egyptians, who adapted their agricultural systems to the flooding rhythms of the Nile, did so through flexibility, cooperation, and innovation. Those that failed, like the ancestral Puebloans or the Norse Greenlanders, often clung to rigid systems or ignored signs of impending change. Today, humanity stands at a similar crossroads. Will societies adapt rapidly enough to avert disaster? Or will political divisions, economic interests, and short-term thinking hinder collective action?
The climate crisis also challenges the stories we tell about ourselves. For centuries, the dominant narrative of industrial civilization has been one of progress, of humanity rising above nature, using knowledge and technology to conquer obstacles and shape the world. But climate change reveals the limits of this narrative. It reminds us that we are not outside the natural world, but deeply embedded within it. Our achievements carry consequences. Our technologies alter ecosystems. Our choices shape the fate of species, landscapes, and future generations. The challenge now is to craft a new narrative, one that recognizes humanity's power not only to harm, but to restore, protect, and steward the planet. Looking ahead, the future of climate and civilization is not predetermined. Scenarios range from catastrophic to hopeful, depending on the actions taken today. If greenhouse gas emissions continue unchecked, temperatures could rise to levels that destabilize food systems, submerge coastal regions, and trigger mass migrations. Economic and political instability could follow, echoing past collapses but on a global scale. Yet if societies commit to rapid decarbonization, invest in clean energy, protect ecosystems, and accelerate adaptation, the world could chart a different course, one marked by sustainability, resilience, and a renewed harmony between human civilization and the natural world. The lessons of history are clear. Climate change has the power to reshape societies, topple governments, and alter the course of civilizations. But history also reveals that humans possess remarkable capacity for adaptation and innovation. The Maya built complex water systems to manage drought. Medieval Europeans developed new agricultural practices to cope with colder temperatures. Communities across Asia, Africa, and the Americas learned to navigate monsoons, river floods, and seasonal cycles with ingenuity and resilience. Today's challenges are larger, but so are our tools, knowledge, and global networks of cooperation. The question that remains is not whether climate change will reshape the world. It already has, and will continue to do so. The question is whether humanity will rise to meet this transformation with wisdom. Will societies choose collaboration over conflict, long-term thinking over short-term gain, and stewardship over exploitation? Will technological innovation be guided by sustainability rather than profit alone? Will nations recognize that the climate crisis transcends borders, ideologies, and generations? The 21st century may ultimately be remembered as the century of choice, a time when humanity confronted its past, understood its impact on the planet, and decided what kind of world it wished to create. The stakes are immense, but so is the potential for renewal. Climate change, for all its dangers, opens the door to reimagining societies. Energy systems powered by clean sources, cities designed for resilience and community, economies aligned with ecological health, and cultures centered on balance rather than consumption. Such visions are ambitious, but not impossible.
As the story of climate and collapse reaches its final chapter, it becomes clear that the future is not a fixed destination, but a landscape shaped by human will. History's environmental shifts remind us that civilizations rise and fall not only with the forces of nature, but with the choices people make in response. Today, the world stands at a threshold similar to those faced by ancient empires and medieval kingdoms, but with the awareness that its decisions will resonate across the entire planet and far into the future. The climate crisis is not simply a scientific challenge, it is a moral one. It demands empathy across borders, generations, and species. It requires courage, imagination, and humility. Above all, it asks humanity to remember that the Earth is not merely a resource, but a home, one shared with countless forms of life, shaped by millions of years of evolution, and entrusted to our care. The final lesson from history is therefore a simple but powerful one. The fate of civilizations is not written in stone, it is written in choices. The choices we make now about energy, land, water, consumption, and cooperation will determine whether future generations inherit a world of scarcity and conflict or one of abundance and stability. The climate may be changing, but humanity still has the ability to shape the outcome. And so the story concludes where it began, not with collapse, but with possibility. The past reveals how climate has shaped civilization. The present shows how civilization is shaping the climate. The future will reveal whether humanity can learn from both and forge a path toward resilience, balance, and collective survival. The next chapter has yet to be written, and it belongs to all of us.
Curiosity never sleeps. Our exploration ends for today, but curiosity never sleeps. So if your mind still seeks answers, subscribe now and keep the fire of discovery alive. We'll see you in the next adventure.
you.